As the BROMEDIR project enters the final month, we at CYRIC, the project coordinator, looking back on a remarkable journey of coordination, innovation and real progress across Europe. Since its launch in January 2023, under Horizon Europe, BROMEDIR sets out to improve the way we detect and analyze chemical and biological substances. Today we are proud to be delivering on that vision, working together with a strong European consortium and turning research into a real solution. Over past 3.5 years we have developed a new generation of miniaturized spectrometer for liquid analysis, compact solution for highly sensitive gas detection, and integrated system that bring together hardware, sensing and data processing. What matters most is that these solutions are not just theoretical, but they are designed to work in real conditions, making advanced sensing faster, smaller and more accessible. In this final phase, our focus has been on testing in real operational environments. BROMEDIR technologies have been applied in sustainable farming, supporting milk quality monitoring, fuel quality control, improving safety in aviation and transport, as well as hydrogen supply chain, helping detect critical impurities. This demonstration shows clearly that the technology is ready to move beyond the lab. As coordinator, CYRIC has worked to keep everything aligned, bringing partners together and ensuring that research leads to working, validated systems. This has truly been a European team effort, with each partner contributing their expertise to a common result. As BROMEDIR comes to an end, its results go beyond the project itself. They open the way for practical sensing solutions that can support industry, agriculture and clean energy.
And our research aims at development of novel sensing technologies based on mid-IR spectroscopy. Within that project, we were working on two different tasks. One task was to advance our photothermal gas sensing technology, which we call ICAPS, interferometric cavity-assisted photothermal spectroscopy, which is a brand new way to do ultra-trace gas analysis in very small volume. And this is exactly the interesting part, because if you can make this system small, it will get more sensitive and more portable and more useful for many different applications. And the opportunity within BROMEDIR was that we were working together with UGE, or we are working together with UGE, because they have the capabilities to make the key components that we need for our gas sensor technology very small. They can even put them on a chip. And within BROMEDIR, we advanced our ICAPS technology towards a chip-based laser gas sensor with ultra-trace sensitivity. The second aspect of that project is the cooperation together with Cyber. Cyber is known for their MEMS FTR spectrometer, and within that project we were exploring the possibility to use these MEMS FTR spectrometers for fuel analysis. In particular, we were interested in the quantification of traces of fatty acid metal ester, also known as FAME, either in biodiesel or in jet fuel.
Aerolytics specializes in developing and manufacturing instruments to test and analyze liquid samples. Our main markets are the fuel, lubricant, and flavors and fragrance. Some of our instruments use infrared spectroscopy. One of our most important instruments is a portable FTIR spectrometer. It is important for our customers to have instruments that have a small footprint. Many of those are used in mobile laboratories or in laboratories where there's already a lot of instrumentation, so there's not a lot of bench space available. Therefore, we are interested in miniaturization, and this is one of the main goals in the BROMEDIR project. Our role is to test the spectrometer. We selected a use case, which is the detection of fatty acid methyl ester, FAME, in diesel fuel. FAME is a renewable energy source, a renewable fuel, and therefore is of a particular interest. Also, what makes it easy to compare the MEMS spectrometer to existing analyses is that there are published ASTM and other standards, and also instruments on the market that perform exactly that analysis. So there's a lot of benchmarks against which we have to, or we can compare the MEMS spectrometer.
We here at TU Wien are responsible for the hydrogen use case in BROMEDIR. In our application here, we separate hydrogen from gas mixtures via a so-called electrochemical hydrogen separator and compressor unit. What you can see in the background is our mixing unit that provides gas mixtures, then humidifies the gas mixtures, and then provides this gas stream to the separation unit. In the separation unit, we have also our sampling ports for testing the so-called PTS spectrometer, here in a field test. What this equipment actually allows from its application is so-called deblending, so the separation of hydrogen from gas mixtures in the gas industry.
In BROMEDIR, we were able to develop the ultra-compact wide-range spectrometer extended up to 10 micrometer. This was achievable by integrating MEMS photonic integrated circuits that was designed by SciWare team, fabricated in University Gustav Eiffel, and integrated with new cooled and uncooled detectors from Vigo Photonics with mid-infrared LEDs from NanoPlus. What we achieved was really incredible, achieving high performance like the lab equipment, and we validated it into use cases, in milk use case and fuel use case, where we were able to achieve lab-grade performance in ultra-compact format.
As coordinator, CIRIC has worked to keep everything aligned, bringing partners together and ensuring that research leads to working, validated systems. This has truly been a European team effort, with each partner contributing their expertise to a common result. As BROMEDIR comes to an end, its results go beyond the project itself. They open the way for practical sensing solutions that can support industry, agriculture, and clean energy. Thank you.